So now we're in the sensor range. So there's many different sensors. This is one of the reasons that I do like the Kinvent product so much, is because everything is under one roof. I started with one sensor and now I've built out to several. And I'll just briefly introduce each. So we have the K push sensor. And for the K push sensor, let me go ahead and share here. This is the one that I basically use all the time. If there's any sensor that is the maximally used in my clinic, in my operation, it would be this one. It's pretty versatile. There are attachments that you can put on it to standardize your pressure. It does have the nice moldable pad for comfort, and it's basically my go-to compression-based device when I'm performing tests and assessments. And so that one is quite common. The next one that I use very frequently, this one is going to be the K pull. And I'm a climber, so I'm using my own carabiners. I connect these to the K pull. I test tension-based dynamometry. Our previous one that we went over, the K push, is pressure-based. The K pull is tension-based. And so with tension-based dynamometry, this is now where I'll get to a couple of the questions that were earlier on. But for tension-based dynamometry, we really need to make sure that the angle of pull is correct. So if we look at, I think this is a question earlier somewhere about the angle of pull. So I'll get to that. I'll summarize it in a moment, but basically make sure that, okay, here we go. Oops. Oh, Barbara, can you put that one back up? I just hit finish. Basically, when you're testing tension-based dynamometry, the angle of pull, user error, is a big deal. And it's easy for numbers to be off because of the angle of application. First of all, that's why you do 3 trials. But you always want to make sure that you have an equalized system. And as you can see here, that you have the ability for this to slide on that letter V so that it is equalized and weighted, so it's not pulling down or sagging. And so having something dual anchored always is the preference and gives the ability to maximize your position and maximize the achievable results. So that's just a small tip for your K pull. And those are tension-based dynamometry, where K push is your pressure-based dynamometry. The other device, K grip, quite easy to use and utilize. You could see here. And with the K grip, it's very helpful. It does have the wrist strap if needed, but very helpful to get dynamometry for grip strength. You have your K move. This is useful. It's a very small device. And so with this, I'm going to go ahead and stop sharing this main screen. With this device, you slide it into typically a band. And I'll use this all the time, maybe a patient with postoperative condition. If I need to measure one type of range of motion objectively over time, it's very helpful to use and utilize. Gives you the exact number, and you can track it over time with their data, and you can provide that for other colleagues, physicians, etc., for the patient to help. So I find this is quite useful to objectively have a number for a patient every time for a certain range of motion. You have the force plates. These are incredibly useful. I'm doing more and more research on rate of force development, on different components. So I like these quite a bit. A little trick on these is you can put some adhesive on the bottom to make them stick onto whatever platform that you're using or utilizing. But those definitely get a lot of use and are quite helpful. The upgraded version of those are the deltas, and those are higher sampling rates, much larger, more for jumping, running, cutting. And I'll go ahead and put the deltas up here. There's a question about, does the weight and height of the individual affect the force results, or does the sensor calculate their absolute strength? Yes, so for anything on a force plate, when they stand on the force plate, it will calibrate. So it'll calibrate to their weight. And when it calibrates to their weight, then it'll use that in the equation to determine the actual outputs. And so that's very helpful and necessary for any of the advanced parameters that you're using. When you're using K-push, you do not have that ability to take the weight into account into the advanced parameters, and the same with K-pull. But you can put their weight as a note in their profile, and then you can actually make a calculation. It's quite simple for strength to weight ratio. But that would have to be a manual calculation, but maybe something that could be suggested maybe in the future for the app interface. So hopefully that answers that question from Ellie. Now the other devices, the K-Bubble. K-Bubble is really interesting. I actually really like this device. There's two different forms of it. And so it's a pneumatic dynamometer. And essentially you put the pressure right into here. As someone squeezes, it then has the reading that goes through the sensor into the app. So for surfaces that are uncomfortable to test, or ones that don't conform really well, it's quite a useful tool. I use that one quite a bit. And that's the kind of the suite of products